But the telecom world is shifting, and towers are no longer just steel structures with radios bolted on. They're becoming intelligent. And the driving force behind that intelligence is machine learning. In this video, we'll walk through how machine learning is quietly transforming mobile towers from old-school BTS sites into smart, predictive, self-optimizing network nodes. We'll look at what this means for network operators, telecom engineers, and of course, for you and me. So let us start with a big question. What exactly was wrong with the traditional way of doing things? Traditional base stations were reactive. Something breaks, you fix it. Congestion happens, you go and tweak some parameters. A whole area underperforms, you send a team, they gather logs, do drive tests, compare performance indicators, and test again. Everything depended on manual interventions, planned optimizations, and regular checkups. Engineers had to guess, test, and keep tweaking. And even then, many problems went unnoticed until subscribers started complaining. Machine learning changes that dynamic completely. ML systems don't wait for alarms to go off. They learn patterns from the vast amounts of data flowing through the network. They identify unusual behavior. They flag issues before an engineer even notices something is wrong. And in many cases, they can even respond automatically. The first major shift is predictive maintenance. Instead of waiting for outages or hardware failures, machine learning models observe everything: power fluctuations, temperature patterns, battery performance, even how the site responds during peak load. Over time, the model learns what normal looks like for each specific tower. It can then spot the early warning signs that a piece of equipment might fail. So instead of a report after a major outage, technicians now get alerts suggesting which site is likely to go down next week and why. They can replace components before they break, send a team before the site collapses, or even manage the risk remotely. This reduces downtime, saves a ton of money, and protects the network's reliability. The second big shift is in anomaly detection. A human engineer might miss subtle changes in performance because there are thousands of cells and millions of data points flowing every single hour. But machine learning doesn't miss these patterns. It can pick up on unusual spikes in drop calls, slight changes in latency, or low data speeds on specific channels. This is the kind of intelligence that makes modern networks far more stable and secure. Another huge transformation is dynamic self-optimization. Now, self-organizing networks, or SON, have existed for a while, but they were mostly rule-based and pretty limited. Machine learning takes it much, much further. Instead of fixed rules, the system looks at traffic load in real time and adjusts things like the antenna's tilt, its power, and how it hands over your phone call to the next tower all automatically. The site essentially tunes itself based on what's happening right at that moment. Imagine a tower in a busy market area. Traffic skyrockets during the day and drops drastically at night. An ML system can balance the load across different parts of the tower, offload users to neighboring sites if it gets too crowded, and even allocate resources differently based on the hour and the expected pattern. This is far beyond what traditional network optimization could ever do. Machine learning is also reshaping energy efficiency. With fuel costs rising and power supply challenges in many parts of the world, keeping towers running consumes a huge chunk of a network operator's budget. Machine learning can predict energy usage, intelligently reduce the power of radios when traffic is low, and optimize the use of battery backups. Some modern sites can even decide when to put certain parts of the radio to sleep during low usage hours, saving enormous costs without affecting your experience. One of the most exciting areas is user experience prediction. Machine learning models can simulate real user behavior based on historical data. They can predict when a certain area will get congested, when a festival crowd will overwhelm the network, and when certain apps will cause a spike in traffic. Operators use these insights to plan for more capacity, deploy temporary solutions, or expand their network ahead of time. Instead of reacting to congestion, networks can now prepare for it before it even happens. And it doesn't stop there. In the backhaul layer, which connects the towers to the core network, machine learning is improving the reliability of microwave links by predicting weather interference and capacity issues. It learns how heavy rain affects specific links and recommends adjustments in real time. Let's not forget about security. Unauthorized access to tower sites, illegal signal boosters, and suspicious signaling patterns can all be flagged by ML models trained to detect abnormal behavior. This brings a whole new level of protection to this critical infrastructure. So, what does all this mean for the telecom engineers on the ground? It means their role is evolving. Instead of spending all day tweaking parameters manually or analyzing logs line by line, engineers now guide the models, validate the insights they provide, and fine-tune the decisions driven by machine learning. The work becomes more strategic and less repetitive. Engineers are still absolutely critical, but now they operate alongside intelligent tools that make them far more productive. For smaller operators and internet service providers, this shift is even more powerful. A few years ago, only the largest telecom companies could afford sophisticated analytic systems. Today, cloud-based machine learning tools allow even local providers to gain these predictive insights without needing a giant budget. This democratization of intelligence is changing the entire telecom landscape. From an end-user's perspective, the benefits are crystal clear: fewer outages, better call quality, faster internet speeds, more stable connections, and more consistent network performance, whether you're in a city or a rural area. Machine learning is turning mobile towers from passive structures into living, learning parts of the network. They adapt. They predict. They correct themselves. And they get smarter with every single data point they receive. We're witnessing the beginning of a network that no longer waits for humans to fix it, but one that understands itself and evolves automatically. The future of telecoms isn't just about 5 or 6G. It's not only about higher speeds. It's about intelligence. It's about smarter infrastructure. And it all starts right at the tower. So the next time you look at a BTS or drive past a tower on the highway, remember, that tower might already be a lot smarter than you think. And this intelligence is only going to grow. If you enjoyed this breakdown and you want more content around AI and telecoms, network automation, and the future of connectivity, make sure to subscribe. There's a lot more to unpack. Thanks for watching.